Hello, I hope this video becomes a blessing. My name is Dr. Isaac Ejekon. I hope the content of this particular video helps prepare you to understand rates of chemical reactions. So what is rate? So first I want to define rate, then we're going to relate it to a chemical reaction. Rate is just the measurement of how fast or slow something is made or something is consumed. I'm going to repeat it. Rate is just measuring how fast something is made or something is consumed over a time duration. So let's just bring this home. So let's say you are in the house and mommy calls you that food is ready. So you are handed this very huge, I'll say a lot of rice in a bowl. We're going to measure how fast you finish this rice over a time period. Okay, so this is the bowl after you finish eating. So let's start from time zero. Time zero is when your mother just finished serving. So at time zero, your bowl is full of what? Rice. After 10 minutes, because you love food, you might have finished half of the quantity of rice that was originally present. After 20 minutes, the amount of rice in a bowl would have reduced drastically again because you are eating or you're consuming the rice in a bowl. Then let's say after 30 minutes, we come back and check on you and the bowl is empty. It's empty. So if we look at this graph, we are measuring how fast you are consuming this rice over how many minutes? 30 minutes. So that is basically rate. So we are measuring. So if I want to write rate or the rate equation for this analogy, then I'm going to say that my rate equals the change in the amount of rice over the change in time. Okay, so if I want to add some numbers, then I could say in relation to this particular analogy, okay, what I just explained here, I'm going to say my rate equals the change in the amount of rice eaten. Rice eating over time. What is the time? The time was what? 30 minutes. You finish this rice in 30 minutes. Now, this 30 minutes written here is actually change. Why is it change? Whenever we measure change in chemistry, if I'm saying that rate in the example I gave equals the change in amount of rice, then I'm going to say that the final amount of rice minus the initial amount of rice over the final time minus initial time. Okay, initial time. So if we had a means of measuring, for example, in grams, the amount of rice, so let's assume that the original amount of rice in grams was about, let's say 10 grams of rice to start off. Okay, that is what mommy served. After 30 minutes, we measure the amount of the remaining amount, and let's say you're a clean eater, so you add everything in a bowl. So you're going to say the bowl is empty. Okay, the bowl is empty. So 0 grams. And this you did from what? Initial time when mommy served was 0, and you took what? 30 minutes to finish it. So if I want to calculate how fast or the rate for this particular event is going to be the final amount of rice. What is the final amount of rice? 0 minus the initial amount of rice. Again, I said, let's assume when mommy served without you touching the food, you had 10 grams. So 10 grams, let me just add the units, over the final time you finished eating at 30 minutes. But when the food was given, that was before you touched it, it was what? 0 minutes. So if you do the math, this is going to be what? Negative 10 over, now this is negative 10 grams over what? 30 minutes. So this is basically 1 over 3, which is 0.33. The unit is going to be grams per minute. Grams here per minute. Okay, now so this is the rate at which you were eating. You were eating 0.33 grams for every minute, or within a span of a minute. This is how much you were taking, 0.33 grams. Now, why is it negative? Okay, so why is it negative? So let me just write it here. So minus 0.33 grams per minute. It is negative because it is consumed. Okay, whenever you consume anything in chemistry in relation to rate, it's going to be negative. So let's bring this home to chemistry. I have what? A plus B equals C. These are your reactants. This is your product. Okay, so if I'm going to measure rate of A, now reactants make product. Okay, you make product out of what? Your reactants, meaning that to make your product you have to consume your reactants. Now because you are consuming a reactant like your rice, rate with respect to your reactants will be negative. So for example, the rate with respect to just reactant A is going to be change in the concentration of A over what? Time. The change in time. But remember, because this is a reactant, that rate is going to be what? Negative. Now if I want to measure rate with respect to a product, in this case my product is what? C. Because products are formed, the rate is positive. So remember, when I defined rate, I said it is how fast or slow something is consumed or produced. So rate in terms of a reactant is negative because it is consumed. Rate with respect to a product is going to be positive. So if I want to write rate with respect to C, which is a product in this equation, then my rate equals what? Change in the concentration of C over changing time. Now, I'm saying concentration, I've not introduced concentration. I'm assuming you know. If you don't know, we're going to measure rates with respect to concentration in chemistry or in a chemical reaction. So I hope you understand what rate is, or rate of a chemical reaction. So basically, for a chemical reaction, we are going to define rate as the change in concentration of your reactant with time, or the change in the concentration of your product with time. Pause the video and see if you can define rate of a chemical reaction. It is the change in the concentration of reactants with time, or the change in concentration of products with time. There's some few things I want to touch on. All right, so let's see. Um, just a second. Okay, let me get my pen writing. All right, so let's look at the factors that affect the rate of a chemical reaction. So factors affecting rate of a chemical reaction. So one of the questions that you might be asked or would be list the factors that affect a chemical reaction, the rate of a chemical reaction. The first factor we want to look at is concentration. Okay. Now, how does concentration affect rate? So I'm just going to write this. I'll say relation. Rate is proportional to collision frequency, and collision frequency is proportional to concentration. And I'm going to explain all this. Okay. All right. So how are these related? We are saying rate is proportional to collision frequency, and collision frequency is proportional to concentration. So all that we are saying is that for rate to increase, you need to increase collision between your molecules, the molecules that make up the reaction or that are involved in the reaction. Okay, so you need to increase the collision between reactants if your aim is to make products. And how is that going to affect, or how is that related to concentration? So let's see. If I have a reaction vessel, okay, that is just, let's say, a cylinder that I'm going to do my reaction in. I have A, B, B, and my end product is to form the compound AB, meaning that A must react with B. Here, they are just by themselves. So we are saying that to make AB, which is our product, A must react with B. But for this reaction to occur, A must collide with B. Okay, A must collide with B. Now, guess what? If I increase the amount of what? A and B, that is increasing concentration, okay? So if I have the same volume, but this time I have what? A, 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 B, 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 A, B, 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 A, A. Now, the volume remains the same, but I've increased the amount of what? A and B. What do you think is going to happen? You're going to have more collision. You're going to have what? A and B colliding more. They're going to have more of what? That collision that we need. So this is going to collide with that. Just a second, my stylus fan is acting up. All right, so A collides with B. This A can collide with this B. This will go here. So there's a lot of collision. And we are saying that as we increase the frequency of collision, A colliding with B, then I'm going to what? Increase rate. Okay. If you have very few or the concentration is low, your collision is really limited, because what if this A decides to move in this direction and this B decides to move in this direction? You don't have that collision, so you are going to really not make A and B unless they move in what this direction. But if you look at this volume, we have so much that in whichever direction they choose to go, there's going to be some sort of collision. And just to re-emphasize, you are going to make more product the more collisions you make, the more collision. So we are going to say that as we increase concentration, so as concentration increases, what is going to happen? We increase what? The collision frequency between reactants. And as we increase the collision frequency between reactants, we are going to increase what? Increase rate. So if you are asked by a teacher, how does concentration affect rate? All you need to remember is that rates can be related to collision frequency and concentration. When you increase concentration, you are increasing collision frequency, and as you increase collision frequency, you are increasing rate. That is all. All right, let's look at the second um, thing that affects rate. Now we want to look at temperature. Okay, temperature. Now, the main or the key word I want you to note in all these factors that affect the rate of a chemical reaction is what? Collision frequency. You have to get used to this word. Whenever this increases, that is the collision frequency increases, what is going to happen? Rates would also what? Increase. The rate of the chemical reaction would also increase. So let's see how these can be related to temperature. So let's go back to the analogy of A and B. A, A, B, B, A, B, A, B. My end goal is to make product what? AB. Okay, AB. So how does temperature affect rate? Temperature. So in very simple terms, we are saying that when you increase temperature, you increase the kinetic energy, okay? The kinetic energy of the molecules. Now, because you've increased the kinetic energy of the molecules, that is going to cause them to move very fast, okay? And because they are moving so fast, you are going to increase the number of what? Or the frequency of what? Collision. So, when you increase temperature, you increase the kinetic energy of the molecules. The molecules gain energy. As to gain energy, that is going to lead to an increase in the collision frequency. And as collision frequency increases, you increase what? The rate of chemical reaction. Okay, so again, in very simple terms, temperature. By increasing temperature, you are giving energy to the molecules. Once these molecules gain energy, which is kinetic energy, that is going to cause them to move so fast that they are going to collide with each other. The more collisions you have, which we call the frequency of collision or collision frequency, you are going to increase what rate. So I hope when you are asked to explain how temperature affects rate of a chemical reaction, you can do so. Now, the last factor I want us to discuss is physical state. So, physical state. Okay. As I've already emphasized, with almost every factor that affects rate, the main word is what? Collision frequency. How frequent your reactants are colliding with each other. So just to simplify everything, if I have something in the solid form compared to it in a liquid state, okay, or if I'm able to change this into, let's say, a powder, I think that is, yeah, let's compare the solid state to the powder state. That would be make a better explanation. So this is the same thing. I've converted it into what? The powder form. Now, because the particles of this solid in the powder form are so fine, we say they have what? A greater surface area. So greater surface area. Now, because they have a greater surface area, then it allows what? Contact or more contact between the particles that make up the solid. So because you have more contacts, then what is happening is you are increasing collision frequency. And because you're increasing collision frequency, guess what? Rate is going to also increase. So I just don't want to put too many words in your head. All I just want you guys to note is in explaining the factors that affect rate, which I've gone through concentration, temperature, and now we are discussing physical state. The main word is collision frequency. So if I have a solid and I break the solid down to a fine particles or into a powder, what I've just done is basically increase the surface area. By increasing the surface area, I'm just giving the molecules more opportunity to what? Collide with each other. Hence, I'm increasing collision frequency. As collision frequency increases, guess what? We are increasing rate. I hope this video helps you. Watch out for the continuation later on. Bye bye. Rate.